Hi everyone, today I'd like to touch one little problem which is often faced by people who use gaming engines like Unity. Nowadays Unity gets more and more attention for industrial workflows to prepare augmented reality, virtual reality, mixed reality scenes for example, and also of course it has its classical use to create games. And let's imagine that on the other end you have a real CAD system. And that could be just anything. It can be SolidWorks, for example, CATIA, NX, or any other CAD design package which is used to generate precise geometries in formats like STEP. So we have a CAD world on the left and we have a gaming world on the right. And then the question is, how would you bridge those two worlds? And actually it's quite possible with Unity, because Unity it accepts files in FBX format. But that's not the only way of importing CAD assets to Unity, because you might also want to create like a plugin for Unity. And there is a bunch of commercial software packages which monetize bridging this gap. So the question is, can we use some open source or at least free tools to not to pay anything and have this conversion done? And the answer is yes. For that we are going to use an open source framework which is Analysis Situs, and you can go to analysissitus.org and download this software from there by clicking this download button over here or just compiling this whole thing from sources. Another ingredient to solving this conversion problem is using this Autodesk FBX software development kit, or shortly SDK. This SDK is not open source, but it's free and you can use it to convert your industrial content to FBX format. Here in Analysis Situs what we are going to use is to give some commands to this ActiveScript console over here. I have a small script prepared for this demo. So let's try to take advantage of this conversion and this Autodesk FBX SDK. So what I am going to do now, I am going to load this step file containing my CAD assembly to a model which is internal representation of a assembly document in Analysis Situs. What will happen under the hood is OpenCascade is going to read this step file into the internal data structure. And all metadata such as colors, names and assembly structure will be preserved. Actually we're not going to see anything on the screen because everything is done in sort of a batch mode and you will only have this data in memory upon completion of this conversion. But we do not really need this visualization things, because what we are going to do, we are going just to convert this whole thing to FBX and then import it to Unity. And then we could manipulate our scene in Unity itself. Once importing is done, we can check that we really have some data in memory by going like awesome xd browse and then we give it a name of the model. And here in this small window we see the assembly structure with all the names, instances and subassemblies. We are not going to do a lot about this right here, and instead we will just generate an FBX file out of this in-memory structure. But before we can do so, we also need to generate triangulation out of these BREP geometries, because right now what we have in memory is precise geometries. And what we need for Unity is a set of triangulation. So let's generate triangles by going like awesome xd generate facets. So here again you need to give it a model name, and then also you give it a qualifier which would specify how coarse your triangulation is going to be. So I will pass here normal. And you see that each individual part is being faceted right now. So that together with my precise BREP geometry, I will also have a set of triangulations associated with every BREP face. And now I am ready to export this whole thing to FBX. So let's do this and let's go like awesome xd, then save FBX, and then we give it a model name once again and a file name for the outcome FBX file. Once the export is done, we can go to Unity and here we can import this FBX asset. And now we can simply drag and drop this whole thing to the scene. And here you will immediately notice that the assembly structure is preserved in the scene tree. So we have the whole hierarchy here, and we can also manipulate this scene as we would expect it to be here. So now you can use this asset for your downstream scenarios. Thank you for watching.